In 1989, a group of Soviet scientists lowered a high-sensitivity microphone to a depth of 12,000 meters into the deepest man-made hole on planet Earth. They expected to hear seismic vibrations, the movement of tectonic plates. But what the microphone recorded made some of them resign the very next day. From a depth where sunlight has never reached, where the temperature exceeds 200 degrees, where pressure could crush a submarine, they heard screams. Thousands of voices, screaming in unbearable agony. It spread across the world in a matter of weeks. A Finnish newspaper published the story. Russians drill their way to the underworld. American televangelists broadcast it live. 300 million people around the globe heard this recording. Religious organizations declared it proof that hell exists. Scientists called it a hoax. The government said nothing. But here's the strange part. The borehole is real. It actually exists. It really is the deepest man-made point on the planet, and what Soviet scientists actually found at that depth, in many ways turned out to be more terrifying than any legend. Because the real story of the Kola Superdeep Borehole is a story of 24 years of obsession, impossible discoveries, ruined lives, and secrets that our planet keeps right beneath our feet. This is the story of how humanity tried to drill to the center of the Earth, and why the Earth would not allow it. Before we descend into this borehole, let's talk about how little we know about the planet we live on. Here is a fact that is almost impossible to process. The distance from the Earth's surface to its center is 6,371 kilometers. The maximum depth humanity has ever reached is 12 kilometers. We have covered 0.2% of the journey. If you imagine the Earth as an apple, we haven't even drilled through the skin. We have scratched the skin. We have sent probes to the edge of the solar system. We have photographed the surface of Pluto from 5 billion kilometers away. We have found water on Mars. But we have no idea what lies 15 kilometers directly beneath our feet. Our entire model of Earth's interior structure is a theory. An educated, well-supported theory, but a theory nonetheless. We have never seen the mantle directly. We have never touched the core. Everything we know is an interpretation of seismic waves. Sound waves from earthquakes that travel through the body of the planet and refract differently in different layers. It's like trying to figure out what's inside a locked safe by the sound it makes when you knock on it. Here is what science knew about the structure of Earth's crust by the middle of the 20th century. The upper layer is granite, 15 to 20 kilometers thick. Below it, basalt. The basalt layer is thicker, 20 to 30 kilometers. Between them, a clear boundary called the Conrad discontinuity, named after the Austrian geophysicist Victor Conrad, who predicted its existence in 1925. Even deeper, 30 to 70 kilometers from the surface, lies the Mohorovičić discontinuity, or simply MOHO, named after the Croatian seismologist Andrija Mohorovičić. This is the boundary between the crust and the mantle, the threshold beyond which an entirely different world begins. This entire model was elegant, logical, universally accepted, and almost entirely wrong. But we will learn that later. 1957. The world is split into two camps. The Iron Curtain has drawn a line across Europe. The Soviet Union and the United States are competing in everything: nuclear weapons, satellites, rockets. On October 4th, 1957, the USSR launched Sputnik 1. The world was in shock. America was humiliated. But behind the headlines about space, behind the footage of rocket launches and satellite dishes, another race was quietly beginning. A race downward. The idea was simple and insanely ambitious. Drill through the Earth's crust entirely. Reach the mantle. Obtain a sample of the substance that makes up 94% of our planet's volume. The Americans were the first to speak about it. In 1957, a group of American scientists gathered over breakfast in the wine cellar of Walter Monk's house in La Jolla, California, and proposed an idea: drill through the ocean floor to the mantle. They called it Project Mohole, after the Moho boundary they intended to reach. The logic was straightforward. Why drill 30 to 50 kilometers through thick continental crust when you can drill just 5 to 7 kilometers through the thin oceanic crust? The project received support from the U.S. National Science Foundation. Budget allocated, platform constructed. In March of 1961, drilling began. The drilling vessel CUSS-1 was stationed in the open Pacific Ocean near Guadalupe Island, off the coast of Mexico. Water depth, 3,500 meters. They had to drill directly from the ocean surface. The task turned out to be monstrously difficult. The vessel was rocking on the waves. The drill string, 3.5 kilometers long just to reach the bottom, swayed like a giant pendulum. Positioning accuracy was critical. The slightest shift of the vessel, and the pipe would snap. They managed to drill 183 meters into the seabed. They passed through 13 meters of sedimentary rock and entered basalt. It was an achievement, the first time in history anyone had drilled through the deep ocean floor. But 183 meters out of the needed 5,000 was 3% of the journey. Then, the chaos began. The budget ballooned. The initial estimate of $15 million grew to $100 million, a colossal sum at the time. Project management was inefficient. Scientists argued with engineers. Engineers argued with contractors. Everyone argued with Congress. In 1966, Congress pulled the funding. Project Mohole was shut down. The equipment was sold at auction for $23,000 as scrap metal. An American congressman commented, "Project Mohole is not a hole in the ground. It's a hole we've been throwing money into." In Moscow, they watched with enormous interest. The Americans had failed. That meant there was an opportunity. For the Soviet Union, a project like this carried not only scientific, but enormous ideological significance. If Soviet scientists could succeed where the capitalists had failed, it would be proof of the superiority of the socialist system. And there was a practical dimension too. The USSR desperately needed data about the deep structure of the crust: oil, gas, minerals. The better we understand what lies at depth, the more efficiently we can extract resources. In the early 60s, a special interdepartmental scientific commission was created under the State Committee for Science and Technology. It was headed by academician Nikolai Alexandrovich Belyavsky, one of the country's foremost geologists. The commission considered several drilling locations: the Ukrainian Shield, Kazakhstan, the Urals, Azerbaijan. After lengthy debates and expeditions, the choice fell on the Kola Peninsula. The Kola Peninsula, the far northwest of Russia, above the Arctic Circle. If you look at a map, it's that tail sticking up between Finland and the White Sea. In winter, there are 42 days of polar night. The sun does not rise above the horizon at all. Temperature, -30, -40 degrees Celsius. Wind so strong it knocks you off your feet. In summer, the polar day. The sun doesn't set, but it's not much warmer, +10, maybe 15. The place is harsh, inhospitable, and absolutely ideal for drilling. Here's why. The Kola Peninsula sits on the Baltic Shield. This is one of the most ancient and stable sections of Earth's crust on the planet. The age of the rocks reaches 3,600,000,000 years. That is more than 3/4 of Earth's entire history. There are no volcanoes here, no earthquakes, no active tectonic faults. The rocks have been compressed to incredible density by billions of years of pressure. But most importantly, ancient rocks that elsewhere lie buried kilometers below the surface are exposed right at the top here. This means that as soon as you start drilling, you immediately enter interesting territory. No need to bore through kilometers of young, boring sedimentary rock. There was another factor too. Geophysical data indicated that right here, on the Kola Peninsula, at a depth of around 7 kilometers, the Conrad discontinuity should pass, that famous boundary between the granitic and basaltic layers of the crust. and at a depth of 15 to 18 kilometers, the Mohorovičić discontinuity. Scientists dreamed of reaching at least the first of these, to see with their own eyes, or rather with their own hands, what this mysterious boundary actually was. The drilling site was chosen 10 kilometers from the town of Zapolyarny, Murmansk Oblast. Coordinates: 69 degrees, 23 minutes north latitude, 31 degrees, 31 minutes east longitude. Nearby, nothing. Tundra, lakes, rocks, low shrubs barely surviving in this climate. Here, in this god-forsaken place, the Soviet Union began its most ambitious scientific project. Before we talk about technology and records, let's talk about the people. Because behind every meter of this borehole stand real people, with names, families, destinies. People who spent decades of their lives in the frozen tundra above the Arctic Circle, devoting themselves to a single hole in the ground. The central figure in this story is David Mironovich Guberman. Born in 1930, a drilling engineer, doctor of technical sciences, a man of extraordinary stubbornness and obsession. Guberman arrived on the Kola Peninsula in 1965 when he was 35 years old. He took charge of the project and led it until the very end. He stayed there for 30 years. 30 years, above the Arctic Circle. 30 winters in polar darkness. 30 times he watched the sun disappear below the horizon for 42 days. His colleagues remembered that Guberman treated the borehole like a living creature. He would say, She's being difficult today. She doesn't want to let us go deeper. She showed us something interesting." Under his leadership, hundreds of people worked: drillers, geologists, geophysicists, geochemists, engineers, technicians. In the best years, over 500 people staffed the station. It was a small scientific city in the middle of the tundra. The scientific consultant for the project was Yevgeny Alexandrovich Kozlovsky, the USSR Minister of Geology. He secured funding and political support for the project at the very top. Without his patronage, the borehole would have been shut down far sooner. The lead scientific advisor in geophysics was Yuri Nikolaevich Yakovlev. His team interpreted the data retrieved from the depths and published results that stunned the global scientific community. But there were also ordinary drillers, people who stood at the rig at 3 in the morning in -35, people who heard the borehole scream, the piercing whistle of gas escaping from the shaft, people who risked their lives every single day. The work was dangerous. Drilling fluid could burst from the borehole under pressure, what's called a blowout. Gases from the deep, hydrogen, methane, could ignite. Steel cables and pipes under hundreds of tons of stress could snap and kill. Accidents happened. Not everyone came home, but they kept drilling. May 24, 1970. The first drill bit touched the rock of the Kola Peninsula. The official start of drilling the Kola Superdeep Borehole. Designation SG3. Let's break down how the drilling process works. Without understanding this, it's impossible to grasp why the project took 24 years and cost hundreds of millions of rubles. Imagine a long steel pipe, a very long one. At the bottom end of the pipe, a drill bit is attached, the cutting tool. It comes in different types: roller cone with rotating toothed wheels, or diamond-tipped coated with industrial diamonds. The bit rotates and chews into the rock. Down through the pipe continuously flows drilling mud, a special heavy fluid made of clay. The mud serves several functions. It cools the bit, which heats up from friction. It carries destroyed rock, called cuttings, back to the surface. It supports the borehole walls and prevents them from collapsing, and it creates counterpressure so that gases and fluids from the deep don't burst upward. Sounds simple, but the devil is in the details. When the depth is 1 kilometer, the pipe weighs several tons. You can control it. At 5 kilometers, the pipe weighs several dozen tons. It begins to flex under its own weight. Rotating it becomes increasingly difficult. At 10 kilometers, the pipe weighs more than 200 tons. It no longer behaves like a rigid rod. It behaves like a flexible rope. It bends, twists, vibrates. Controlling it is like trying to thread a 12-kilometer-long piece of cooked spaghetti through the eye of a needle. And that is not a metaphor. Engineers on the Kola project actually used the term spaghetti effect to describe the behavior of the drill string at extreme depths. The diameter of the borehole changed with depth. At the surface, 92 centimeters, almost a meter. A person could fit through it. But with every kilometer, the borehole narrowed. At a depth of 12 kilometers, the diameter was 21.5 centimeters, smaller than a dinner plate. Imagine that, a dinner plate, and beneath it, 12 kilometers of absolute darkness, heat, and pressure. One more thing that is hard to comprehend: time. To lower the drilling tool to a depth of 10 kilometers takes approximately 18 hours. To pull it back up, another 18. That's 1.5 days just to lower and raise the pipe. Once. And the drill bit at that depth lasts only a few hours, sometimes only a few minutes. Then it wears out and needs to be replaced. This means 1.5 days of lowering and raising, for a few hours of drilling, for a few meters of progress. At maximum depth, the drilling speed was about 10 centimeters per hour. 10 centimeters per hour. That is slower than grass grows. The first 5 years, from 1970 to 1975, drilling was done with a standard rig, the Uralmash 4E. This was an off-the-shelf industrial unit designed for oil and gas wells. Powerful, reliable, but built for depths of 5 to 7 kilometers. The drilling method at this stage was conventional, rotary. The entire drill string rotated as one piece. A rotary table on the surface turned the pipe. The pipe turned the bit at the bottom. The pace was decent. The first kilometer was reached relatively quickly, then the second, the third. Each kilometer was a celebration, each kilometer a new record for the project. By 1973, the depth reached 7,000 meters. By 1975, 7,263 meters. 5 years, 7 kilometers. An excellent result. But at that depth, it became clear the standard rig could go no further. Problems were multiplying. The temperature at the bottom of the hole had reached 120 degrees Celsius. Drill bits lasted less and less. Mechanical stress on the drill string was approaching critical levels. And most importantly, the rotary method no longer worked. Spinning a 12-kilometer column as a single piece is like trying to spin a steel cable stretching from one end of a city to the other. The energy spent rotating the pipe itself was several times greater than the energy that actually reached the bit. A fundamentally different approach was needed. Drilling was halted for 2 years. During those 2 years, engineers at the Ural Heavy Machinery Plant designed and built a unique rig, the Uralmash 15,000. The number 15,000 in the name referred to the target depth, 15 kilometers. It was a machine with no equal anywhere in the world. A derrick 68 meters tall, like a 20-story building. Total weight of the structure? Thousands of tons. But the main innovation was not in its size. It was in the drilling method. Instead of rotating the entire string, the engineers used a turbine method. At the bottom of the string, just above the bit, they installed a turbo drill, a miniature turbine spun by the flow of drilling mud. The mud was pumped under pressure from the surface, passed through the turbine, spun the bit, and returned upward through the space between the pipe and the borehole walls. This meant the entire 12-kilometer string remained stationary. Only the bit at the very bottom rotated. A revolutionary solution. A Soviet innovation. This is what made it possible to drill the remaining 5 kilometers. In 1977, drilling resumed on the new rig. 1977. The new Uralmash 15,000 rig towers over the tundra like a steel cathedral, 68 meters tall, taller than anything within 100 kilometers. Drilling resumes, and the most extraordinary chapter of this story begins, because starting from a depth of 7 kilometers, every single meter brought discoveries that contradicted everything science knew about the Earth. The first shock came almost immediately. Remember the Conrad discontinuity? The supposed boundary between the granitic and basaltic layers of the crust? The one described in every geology textbook? The one that, in many ways, this entire project was designed to reach. According to seismic data, it should have been located at a depth of around 7 kilometers. This was where the speed of seismic waves changed abruptly. Scientists were certain. At this depth, Granite ends and basalt begins. The borehole passed the 7-kilometer mark. Granite. 7.5. Granite. 8. Granite. 9. Granite. 10. Granite. There was no basalt. Nowhere. At any depth. This was a blow. Not to the project continued. A blow to fundamental geology. To the model of Earth's structure that had been considered proven. The Conrad discontinuity, as it had been imagined, did not exist. The change in seismic wave velocity that scientists had detected from the surface was real, but it wasn't caused by a transition from one rock type to another. It was caused by changes in the physical properties of the same rock. Under enormous pressure and temperature, granite changed its acoustic characteristics. It transmitted sound differently, but it was still granite. The Earth had fooled us. We had been reading the signals from below for decades, and we had read them wrong. This single discovery forced a fundamental revision of the continental crust model. Textbooks had to be rewritten, literally. But this was only the first surprise. There would be many more. 7 kilometers down. 8. 9. The drill was pulling up core samples, cylinders of rock extracted from the borehole. Each sample was a sensation. Geologists literally lined up to hold a piece of stone that hadn't seen the light of day in 2 billion years. And at a depth of around 9 kilometers, they found water. Let me explain why this was impossible. At 9 kilometers, the pressure is roughly 1,000 atmospheres, 1,000 times the pressure at the surface. Under such pressure, any cavity, any crack, any pore in the rock should be crushed shut, squeezed closed like a sponge in a hydraulic press. There simply cannot be free space for water to exist. And yet, there it was, water, at 9 kilometers, flowing through fractures in the rock. Not just any water. This water was unlike anything found on the surface. It was saturated with minerals, extremely hot, and it had been down there for an unimaginable length of time. But how? Where did it come from? There were two hypotheses. The first, this was ancient surface water. Water that had seeped down through microcracks over millions of years. Slowly, molecule by molecule, filtering through solid rock like water through the world's densest, hardest coffee filter. The second hypothesis was far more radical. This water might never have been on the surface at all. It might be juvenile water, generated by chemical reactions deep in the Earth's crust. Hydrogen released from minerals combining with oxygen at extreme temperatures and pressures. Water, born inside the planet itself. If the second hypothesis is correct, it means that the Earth continually produces water from within. That our planet is not a dry rock with water only on the surface. It is a body that sweats, that generates water from its own depths. This changes everything we think we know about where Earth's oceans came from. To this day, the question is not fully resolved. Here is another discovery that no one anticipated. In rock samples from depths of 6 to 7 kilometers, the scientists found microfossils, fossilized remains of ancient microorganisms. 24 species in total. This alone would have been remarkable. But what astonished the researchers was the depth, at 7 kilometers. In rock 2 billion years old, under conditions where no living thing was supposed to exist. Even more startling, some of these microfossils were found in a pristine state, perfectly preserved, as if they had been sealed in stone at the moment of death and remained untouched for 2 billion years. But there was more. In the drilling fluid returning from the greatest depths, instruments detected organic compounds, methane, amino acids, hydrocarbons. This raised a staggering question. Is there life at those depths right now? Not fossils. Living organisms. Microbes surviving in conditions of extreme temperature, pressure, and total darkness. In the 90s, after the project ended, other research confirmed it. Bacteria have been found at depths of 5, 7, even 10 kilometers, living, multiplying, feeding on hydrogen and minerals. An entire biosphere exists beneath our feet, one we did not know about. Now let's talk about heat. because temperature was the main enemy, the enemy that ultimately won. Before drilling began, scientists used the standard geothermal gradient to predict temperatures. The gradient says, for every kilometer of depth, the temperature rises by approximately 25 to 30 degrees Celsius. Based on this calculation, at 10 kilometers, the temperature should have been around 110 degrees. Hot, but manageable. Modern equipment can handle that. At 12 kilometers, the predicted temperature was 140 degrees. Difficult, but theoretically achievable. What they actually found was far worse. The temperature was rising much faster than predicted. The gradient was not constant. It accelerated with depth. At 10 kilometers, the temperature was not 110 degrees. It was 180. At 12 kilometers, it was not 140. It was 212 degrees Celsius, 70 degrees higher than the prediction. At 212 degrees, steel begins to lose its structural properties. It becomes softer, more pliable. Drill bits that were designed to last 12 hours lasted 40 minutes. Drilling mud, which was supposed to stay liquid, began to change its chemical composition. Electronics failed. Sensors gave false readings. But most critically, the rock itself changed behavior. At 200 degrees, rock at that depth stops behaving like a brittle solid. It becomes plastic, almost viscous, like hot tar. When the drill bit pulled away from the rock face, the rock would slowly flow back and close the hole. Like sticking a finger into warm wax and pulling it out, and watching the wax slowly fill the gap. The borehole was healing itself. The earth was literally closing the wound. The engineers called this phenomenon plastic flow. It meant that at a certain depth, drilling becomes physically impossible. Not because we lack the technology, but because the planet itself won't let you keep a hole open. And then there were the gases. Starting at a depth of about 9 kilometers, the borehole began releasing gases. Not a lot at first, a trickle, but enough to set off alarms. Hydrogen, helium, methane, nitrogen. These gases were not supposed to be there, especially not hydrogen, and especially not in those quantities. Hydrogen at great depth is extremely dangerous. It is highly flammable. Mixed with oxygen, it can explode. And it was seeping out of the rock continuously, around the clock, as if the Earth were breathing. Helium was another puzzle. Helium on Earth is produced primarily by the radioactive decay of uranium and thorium. Finding significant amounts of helium at 12 kilometers meant that there were radioactive processes occurring deep in the crust that we hadn't accounted for. The gas composition from the Kola Borehole challenged existing models of deep crustal chemistry. It suggested that the Earth's crust is far more chemically active than anyone had assumed. It is not a dead, static shell. It is a living, breathing, reacting system. Despite all the difficulties, the borehole kept going deeper. Let's walk through the milestones. 1979. Depth: 9,584 meters. The Kola Borehole surpasses the Bertha Rogers Hole in Oklahoma, USA, which held the previous world record at 9,583 meters. The Soviet Union now holds the record for the deepest hole on Earth. This was a national triumph. Newspapers reported it. Television covered it. The Kola team received state awards. 1983. Depth: 12,000 meters. A symbolic milestone. 12 kilometers straight down. Drilling was paused so the results could be presented at the International Geological Congress in Moscow. Scientists from around the world were astounded. Many simply did not believe the data. The temperature readings, the water at depth, the absence of the Conrad discontinuity, it all seemed impossible. But the Soviets had the core samples to prove it. Then came 1984, and disaster. The drill string was at a depth of 12,066 meters. The crew was performing a routine operation, pulling the string up to replace the drill bit. And then, it happened. Somewhere deep below, the string broke. 5 kilometers of steel pipe, about 200 tons of metal, separated from the rest of the column and fell to the bottom of the hole. Lost. Imagine that. 200 tons of pipe. Gone. Stuck at the bottom of a shaft 21 centimeters wide and 12 kilometers deep. There was no way to retrieve it. No tool, no cable, no magnet could reach it and pull it out. 5 kilometers of pipe, 5,000 meters of irreplaceable steel, at the bottom of a hole that had taken 14 years to drill. In an instant, years of work were gone. The silence on the drilling floor that day was absolute. Guberman stood at the edge of the platform, looking down into the borehole for a very long time. He said nothing. Why did this happen? At 12 kilometers, the combination of heat, pressure, and chemical exposure had weakened the steel beyond its limits. The pipe had been going up and down this hole for years. Thousands of cycles of heating and cooling, constant vibration, corrosion from the hot mineralized water and hydrogen gas at depth. Metal fatigue accumulated invisibly, until one moment, the steel simply gave way. It was not a single catastrophic failure. It was death by 1,000 cuts. But the accident raised a fundamental question. Should they stop? 12 kilometers. Already a world record. Already enough data for decades of research. Already proof that the Earth is not what we thought it was. Wouldn't it be reasonable to declare victory and go home? Guberman's answer was no. We are not stopping, he said. We are starting again. Not from the surface. That would take another 14 years. Instead, they would go back to a depth of 7,000 meters, where the original borehole was still intact, and drill a new branch, a deviation, a new path into the deep, bypassing the section blocked by the lost pipe. Think about what this means. They had to steer a drill bit at a depth of 7 kilometers, sideways, and then redirect it downward again, with millimeter precision, through solid rock, at temperatures exceeding 150 degrees. This was not engineering. This was stubbornness elevated to an art form. It took them 6 years. 6 years of drilling the new branch. 6 years of failures, broken bits, collapses, and setbacks. But in 1990, they reached it. 12,262 meters. The deepest point any human-made object has ever reached in the Earth's crust. It still is, as of today. At that depth, the temperature was 212 degrees Celsius. The pressure, approximately 1,000 atmospheres. The diameter of the hole, 21.5 centimeters. The age of the rock, approximately 2,700,000,000 years. The rock at the bottom of the Kola Superdeep Borehole was formed when the Earth had no multicellular life. No plants, no animals, no oxygen in the atmosphere, just microbes, water, and rock. A planet completely alien to us, and they were touching it. Core samples from that depth were treated like moon rocks, stored in special containers, studied in sealed laboratories. Scientists wore gloves when handling them, not to protect themselves, but to protect the samples. These were the deepest pieces of our planet ever held by human hands. But 1990 was not only the year of triumph, it was the beginning of the end. The Soviet Union was dying. Economically, the country was in free fall. Budgets were being slashed across the board. Factories were shutting down. Scientists weren't getting paid. The military was struggling to feed its own soldiers. And here, above the Arctic Circle, 500 people were trying to drill a hole that had no immediate military or economic value. Funding began to dry up. First, they cut the bonuses, then the maintenance budgets, then staff positions. People started leaving, not because they wanted to, but because there was nothing to eat. In 1991, the Soviet Union collapsed. The Kola Superdeep became an orphan. It belonged to a country that no longer existed. The new Russian government had other priorities: survival, feeding people, preventing civil war. A scientific borehole in the Arctic was not on anyone's list. But Guberman refused to give up. He wrote letters to every minister, every deputy, every official he could find. He begged, he argued, he pleaded. Some funding trickled in, enough to keep a skeleton crew, enough to maintain the equipment, not enough to drill. In 1992, the project was formally closed for further deepening. The official reason? Insufficient funding. The real reason? The country could no longer afford to chase a dream. But the station remained operational. A small team stayed behind. They continued to study the existing core samples. They lowered instruments into the borehole to take measurements. They published papers. Guberman stayed. Of course he stayed. Throughout the 90s, the station decayed. The buildings needed repair, equipment rusted. The heating system broke down in winter, and people worked in their coats. Paint peeled from the walls. Windows cracked in the frost and were patched with tape. It looked less like a scientific research station and more like a post-apocalyptic outpost. In 1995, an attempt was made to resume drilling. They got the rig running. They lowered the string, and the borehole collapsed at a depth of about 11.5 kilometers. The rock had shifted over the years of inactivity, squeezing the shaft shut. The earth had sealed the wound while no one was looking. After that, there was no more talk of drilling. In 2005, the project was officially decommissioned. The remaining staff were dismissed. Equipment was shut down. Power was disconnected. The borehole was capped with a rusted metal plate and bolted to a concrete slab. 12,262 meters of human ambition, sealed with 12 bolts. In 2006, the derrick was dismantled and sold for scrap. 68 meters of engineering marvel, converted into a few tons of rusted metal. Guberman, by then in his 70s, finally left the Kola Peninsula. He had arrived as a young man of 35. He left as an old man who had given the best years of his life to a hole in the ground that the world had forgotten. He passed away in 2011. Most obituaries did not mention him. What happened to the others? Most of the scientists who worked on the Kola project scattered across the world after the Soviet collapse. Some went to Western universities. Some went into the oil industry, where their deep drilling expertise was worth a fortune. Some stayed in Russia and continued to publish, though funding for pure geology had all but disappeared. The drillers, the workers, the technicians, the people who actually stood at the rig in the polar night, most of them returned to ordinary lives. Some went to work at other drilling sites. Some retired. Some drank. The transition from a grand Soviet project to post-Soviet reality was not kind to them. Zapolyarny, the nearest town, survives to this day. About 15,000 people. A mining town. Nickel and copper. The residents remember the borehole. Some of them worked there. They speak about it with a mixture of pride and melancholy. "We were doing something important," one former worker told a journalist in 2018. "We were going where no one had gone before, and then one day they told us it was over. Just like that. Over." He paused. "The hole is still there, though. It's not going anywhere." Now, let's return to where we started. The sounds of hell. That recording, those screams from the deep, that story that spread across the world and became one of the most famous urban legends of the 20th century. Let's examine what actually happened. The story first appeared in 1989. A Finnish newspaper, Amenusastia, a Christian publication, printed an article claiming that Soviet scientists on the Kola Peninsula had drilled into a cavity at 12 kilometers depth, lowered a heat-resistant microphone, and recorded the screams of damned souls. The article claimed that the temperature in the cavity was over 1,000 degrees Celsius, that scientists fled the site in terror, that some of them went insane. The story was picked up by Trinity Broadcasting Network, one of the largest Christian television networks in the United States. They broadcast it to millions. From there, it spread to every continent. Within months, the well to hell became a global phenomenon. So, is any of it true? Let's start with what is true. The Kola Superdeep Borehole is real. It reached 12,262 meters. That is a fact. The temperature at the bottom was 212 degrees Celsius. That is a fact. Soviet scientists did lower instruments to the bottom of the borehole. That is a fact. Now, what is not true? There was no cavity at 12 kilometers. The rock at that depth is under such immense pressure that open spaces cannot exist. Any void would be instantly crushed shut. This is basic physics. No microphone was lowered to 12 kilometers. The temperature alone, 212 degrees, would destroy any conventional microphone. There are high-temperature instruments that can function at such depths, but they measure seismic vibrations, not sound in the way we understand it. There is no air at 12 kilometers. Sound as we know it, pressure waves through air, does not exist there. The recording that circulated around the world has been traced back with reasonable confidence. Audio analysts have concluded that it is most likely a heavily modified loop of sound effects, possibly from a horror film soundtrack, with screams layered and distorted to create an impression of thousands of voices. The Norwegian teacher Åge Rendalen later admitted to deliberately adding fabricated details to the story as a prank, to see how far it would spread. He was shocked when American media picked it up without any fact-checking. So the viral recording is almost certainly fake. The story around it is heavily embellished, but almost certainly is not definitely. And there is one detail that complicates the neat debunking narrative. But here is where the story takes an unexpected turn. In the early 2000s, David Guberman, the man who led the Kola project for 30 years, was giving a press conference in Australia. A question came from the audience. "Dr. Guberman, why are you hiding the fact that the Russians dug up something supernatural down there? What the hell did you find?" The scientist paused. He seemed uncomfortable. Then he sighed and answered honestly. "When people ask me about this mysterious story, I don't know what to say. On one hand, all these tales about a demon are complete nonsense. On the other hand, as an honest scientist, I cannot claim that I know exactly what happened. It is true that during one of the drilling phases, our instruments registered a very strange noise. Then, an explosion. Several days later, nothing similar was detected at the same depth. It was never recorded again. I have nothing more to add." Let that sink in. He did not say, "It's all a hoax." He did not laugh it off. The lead scientist of the deepest hole in human history said, "Something strange happened. We recorded it, and we don't know what it was." The Sounds of Hell recording that circulated around the world is almost certainly a fabrication. The screaming souls, the 1,000-degree cavity, the scientists fleeing in terror, that is fiction. But something did happen at depth, some anomalous event that even Guberman, after 30 years at the borehole, could not explain. And that, perhaps, is more unsettling than any urban legend. Because a fake recording of hell is just a hoax. But a real, unexplained event at 12 kilometers depth, confirmed by the project's own director, that is a genuine mystery, one that remains unsolved to this day. Let's take stock. What did the Kola Superdeep Borehole actually give to science? First, the two-layer model of continental crust, granite on top, basalt below, was disproven. The Conrad discontinuity, as a physical boundary between two types of rock, does not exist. The change in seismic wave velocity is caused by metamorphic changes in the same rock under pressure and heat. This was a paradigm shift in geology. Second, free water exists at depths of 9 to 12 kilometers. This challenges our understanding of fluid dynamics in the deep crust and raises fundamental questions about the origin of Earth's water. Third, microfossils and organic compounds were found at depths previously thought to be sterile. This expanded the known boundaries of the biosphere by several kilometers downward. The implications for astrobiology are enormous. If life can exist at such depths on Earth, it might exist beneath the surfaces of Mars, Europa, or Enceladus. Fourth, the geothermal gradient in ancient crystalline shields is far steeper than predicted. This has direct implications for geothermal energy, mining, and our understanding of heat flow within the planet. Fifth, the gas composition at depth, particularly the presence of hydrogen and helium, revealed active geochemical processes in the deep crust that were previously unknown. Sixth, the Kola project advanced deep drilling technology by decades. The turbine drilling method, the development of high-temperature drilling muds, the engineering solutions for managing 12-kilometer pipe strings, all of this knowledge fed directly into the oil and gas industry. In total, the project produced over 5,000 scientific publications, dozens of doctoral dissertations, hundreds of master's theses. The data collected is still being analyzed today, more than 30 years after drilling stopped. The Kola Superdeep Borehole was not just a hole in the ground. It was a window. A tiny, narrow window into a world we had never seen. And what we saw through that window changed everything. Has anyone tried to go deeper since? The short answer is no. Not in terms of vertical depth into the Earth's crust. There are deeper boreholes measured by total length. The Sakhalin-1 well in Russia, drilled by ExxonMobil in 2011, reached a total measured depth of over 15 kilometers. But it is not vertical. It is an extended reach well, drilled at an angle, that travels mostly horizontally. Its true vertical depth is far less than the Kola record. The Al Shaheen well in Qatar and the Maersk Oil BD-04A well are similarly long but angled. In terms of true vertical depth, 12,262 meters remains the record. Set in 1990, over 30 years ago, no one has beaten it. But there are new projects. China launched the Deep Earth initiative. They are planning a series of ultra-deep boreholes across the country, aiming to reach 10,000 meters in various geological settings. In 2023, they began drilling in the Tarim Basin in Xinjiang. Japan's Chikyu drilling vessel is designed to drill through the ocean floor to reach the mantle, the original dream of Project Mohole. They have reached depths of over 3,000 meters below the seafloor, in water over 2,000 meters deep. But the mantle remains out of reach. There have been proposals for more radical approaches. Some scientists have suggested using self-propelled nuclear-powered melt probes that would simply melt their way through rock. Others have proposed using directed energy, lasers, plasma, even controlled nuclear explosions. None of these have moved beyond the conceptual stage. The truth is, we do not currently possess the technology to go significantly deeper than 12 kilometers into continental crust. The combination of temperature, pressure, and rock plasticity creates a barrier that our best engineering cannot overcome. We can send a rover to Mars. We can build a space telescope that photographs galaxies 13 billion light-years away. We can split the atom and map the human genome. But we cannot drill a hole deeper than 12 kilometers. The Earth is keeping its secrets. For now. Today, the Kola Superdeep Borehole is a ruin. If you go there now, and people do, a handful of explorers and journalists make the trek each year, this is what you will find. A dirt road, barely passable in summer, completely impassable in winter. It winds through the tundra for about 10 kilometers from the town of Zapolyarny. At the end of the road, a cluster of abandoned buildings. Concrete walls streaked with rust, roofs caved in, windows shattered, doors hanging off their hinges, Soviet-era signs, faded to the point of illegibility, still bolted to the walls. The drilling hall, where the great Uralmash 15,000 once stood, is an empty shell. The derrick was dismantled long ago. The floor is cracked concrete, pools of standing water, debris everywhere, twisted metal, broken glass, the remains of control panels, stripped of anything valuable. Nature is reclaiming the site. Moss grows on the walls. Small trees push through the concrete. In summer, wildflowers surround the buildings, a strange beauty in the middle of desolation. And in the center of it all, the borehole itself. It's surprisingly unimpressive. A metal cap roughly the size of a manhole cover, bolted to a concrete slab. Rusted, weathered, unremarkable. There is no monument, no plaque, no museum, no visitor center, no sign explaining what happened here. Just a rusted metal disc, and beneath it, 12 kilometers of darkness reaching into the ancient bones of the planet. If you press your ear to the cap, some visitors claim you can hear a faint hum, a vibration. Probably just the wind resonating through the upper sections of the shaft. Probably. Local teenagers from Zapolyarny sometimes come here on dares. They take selfies on the cap. They joke about it being the entrance to hell. They leave beer cans and cigarette butts. 12,262 meters of human achievement, and it has become a place where teenagers come to drink beer. There is something profoundly sad about that, and something profoundly human. Let's step back now. Let's rise above the tundra, above the abandoned buildings and the rusted cap. Let's think about what this whole endeavor means. For 24 years, hundreds of people devoted their lives to drilling a single hole in the ground. They endured polar winters, equipment failures, political upheaval, and the collapse of their entire country. They pushed technology to its absolute limit and beyond. They broke every record, they rewrote textbooks, and they reached 0.2% of the way to the center of the Earth. That number should humble us. We live on the surface of this planet. We build our cities, grow our food, fight our wars, fall in love, raise our children, and die, all on a thin film stretched across the top of a ball of rock and metal that we know almost nothing about. Imagine a basketball. Now imagine a single coat of paint on that basketball. We live on the paint. Everything we have ever known, every civilization, every war, every monument, every ocean, exists on the paint. And we have barely scratched it. The Kola Borehole taught us that the Earth is not a passive, predictable object. It is active, dynamic, full of surprises. It has water where there shouldn't be water, life where there shouldn't be life, heat that defies our models, chemistry that contradicts our assumptions, and it actively resists our attempts to penetrate it, closing holes, breaking our tools, crushing our ambitions under unimaginable pressure. If you are a person of faith, you might see in this a divine message. Thus far and no further. The Earth has boundaries that were not meant to be crossed. If you are a person of science, the message is different but equally profound. Our ignorance is staggering. For all our technology, for all our brilliance, we are infants playing on the beach, to borrow Newton's metaphor, while the vast ocean of the unknown stretches before us. Either way, the conclusion is the same. We do not understand the ground beneath our feet, and the ground beneath our feet does not care whether we understand it or not. There is something deeply philosophical about drilling into the Earth. When we launch a rocket into space, it is an act of reaching outward, of expansion, of aspiration. We are going somewhere new, somewhere we can see even if we cannot yet touch. But drilling into the Earth is the opposite. It is an act of looking inward, of digging into ourselves, into the very body of the world that made us. We cannot see what is below. We can only push blindly downward and see what comes up. In many mythologies, the underworld is a place of truth. In Greek myth, Orpheus descends to retrieve Eurydice, but the real test is whether he can resist looking back. In Norse mythology, the roots of Yggdrasil, the world tree, reach into the deepest wells of wisdom and fate. In Dante's Inferno, the descent through hell is a journey of self-knowledge. The Kola Borehole is, in its own way, a modern myth, a descent into the unknown, a confrontation with the limits of human knowledge and human will. And like all great myths, it ends not with triumph, but with humility. We went as deep as we could. We saw things we didn't expect. We learned that our maps were wrong. And then the Earth pushed us back. Not with violence, not with drama, just with heat and pressure and time. The three things the Earth has in infinite supply, and we do not. There is a Japanese concept called mono no aware. It means the bittersweet awareness of impermanence, the beauty of things that are passing, the sadness of things that cannot last. The Kola Superdeep Borehole is pure mono no aware, a magnificent, doomed attempt to know the unknowable, a beautiful failure, a ruin that speaks louder than any monument. 24 years, 12 kilometers, and then silence. The Kola Superdeep Borehole left behind a long list of unanswered questions. What happens below 12 kilometers? The borehole reached 12,262 meters. That's where the story ends. But the Earth goes on for 6,000 more kilometers. What is down there? We think we know. Seismic data tells us there is a mantle of semi-solid rock, a liquid outer core of iron and nickel, and a solid inner core under unimaginable pressure. But we have never verified this directly. It remains a model, an interpretation, a best guess. What if the model is wrong? The Kola Borehole already proved that our model of the crust was wrong. What if our model of the mantle is also wrong? What if our model of the core is wrong? Here is an uncomfortable truth. The deepest point we have ever directly observed is 12 kilometers. The center of the Earth is 6,371 kilometers away. Everything between those two numbers is inference. We have better direct knowledge of the surface of Mars than we do of what lies 100 kilometers beneath London or Tokyo or New York? Where did Earth's water come from? The discovery of water at 9 kilometers in the Kola Borehole reignited this debate. If the Earth generates water internally through chemical reactions, it means the total volume of water on Earth might be far greater than what we see on the surface. Some estimates suggest there may be several oceans worth of water locked in minerals in the mantle. Is there a deep biosphere? We now know that life exists at depths of several kilometers. But how deep does it go? Are there organisms at 20 kilometers? 50? Is there an entire shadow biosphere beneath us, living on hydrogen and minerals, completely independent of sunlight? Some scientists estimate that the total biomass of subsurface life may equal or even exceed the total biomass on the surface. That is a staggering thought. It would mean that most life on Earth is not up here with us. It is down there, in the dark, in the heat, in the pressure. We are not the majority. We are the exception. The thin film of life that clings to the outside of the planet, bathed in sunlight, breathing oxygen, completely oblivious to the vast living world beneath. Will we ever go deeper? There are reasons to believe we will. Technology has advanced enormously since 1990. Materials science has produced alloys that can withstand higher temperatures. Computational modeling allows us to predict conditions at depth with far greater accuracy. Directional drilling technology, developed for the oil and gas industry, is decades ahead of what was available to Guberman's team. There are active projects around the world. The International Continental Scientific Drilling Program continues to fund deep boreholes, though none approaching the Kola depth. China's Deep Earth Initiative is the most ambitious current program. In May 2023, drilling began on a borehole in the Tarim Basin, targeting a depth of 11,100 meters. If successful, it will be the deepest hole ever drilled in China. Private companies are also entering the field. Quaise Energy, a startup spun out of MIT, is developing a drilling system that uses millimeter wave energy, essentially directed microwave radiation, to vaporize rock. They claim this could make it possible to reach depths of 20 kilometers or more, far beyond what mechanical drilling can achieve. The potential rewards are enormous. At 20 kilometers depth, temperatures could reach 300 to 500 degrees Celsius. That is enough to generate geothermal energy virtually anywhere on Earth. Not just in volcanic regions like Iceland, but everywhere. Under cities, under deserts, under farmland. Unlimited, clean, renewable energy. Available 24 hours a day, 365 days a year. Some researchers call this deep geothermal, the holy grail of energy. If we can drill deep enough, cheaply enough, we solve the energy crisis. Period. There are also implications for mineral extraction. Rare earth elements, lithium, cobalt, the materials we need for batteries and electronics, exist in abundance at depth. If deep drilling becomes economically viable, it could reshape the global economy. And then there is pure science. Every kilometer deeper we go reveals something we didn't expect. The Kola Borehole proved that. Whatever we find at 15, 20, or 30 kilometers, it will surprise us. It always does. I want to leave you with an image. It is night. Polar night. January on the Kola Peninsula. The sun has not risen in 3 weeks and will not rise for 3 more. The temperature is -35. The wind is howling across the tundra at 60 kilometers per hour. The wind chill makes it feel like -50. There is no light anywhere. No city glow on the horizon. No headlights on distant roads. Just blackness. In every direction, to the edge of the world. And in the middle of this darkness, a single light. A floodlight bolted to a concrete wall. Buzzing. Flickering. It illuminates a small patch of ground. Cracked concrete. A rusted metal cap. 12 bolts. Beneath that cap, a shaft drops straight down for 12 kilometers, past layers of rock that were ancient when the first bacteria appeared on Earth. Past water that may have been trapped since before the dinosaurs. Past fossils of creatures that lived and died 2 billion years before anything with eyes existed. Down and down and down. Into heat that would boil water. Into pressure that would crush steel. into darkness so absolute that the concept of light has no meaning. And at the very bottom, the shaft ends, 21.5 centimeters wide, a circle smaller than a dinner plate. Below that circle, 6,359 kilometers of planet that we have never touched, never seen, never directly measured. The inner Earth, the great unknown, the last true frontier. We have walked on the moon. We have driven robots on Mars. We have photographed a black hole. We have sequenced the human genome. We have split the atom and harnessed its energy. But we have not gone deeper than 12 kilometers into our own planet. The frontier is not out there. It is down here, beneath our feet, beneath our cities, beneath everything we know, and it is waiting. The Kola Superdeep Borehole started May 24, 1970, stopped 1992, maximum depth 12,262 meters, still the deepest penetration of the Earth's crust in human history. A monument to human curiosity, stubbornness, and the refusal to accept that some things cannot be known. A reminder that the greatest mysteries are not in the stars above us, but in the ground below us. And a promise, because someday, someone will go deeper. Someday, a drill bit will pass 12,262 meters and keep going, into rock no human has ever touched, into a world no human has ever seen. And when that happens, I hope they remember the people who went first. The people who spent 30 years in the Arctic darkness, drilling a hole that the world forgot. The people of the Kola Superdeep. They went as far as they could. The rest is up to us.